Namaste, welcome to all. Let us define composite function. See, we should have two functions, f maps a to b and g maps b to c. Okay, if you take any arbitrary element, you can write f maps to f of x. Its image can be written as f of x. No, here some y equal to f of x. Okay, next if g maps from b to c, then how we can write y maps to g of y. Okay, instead of y, we can write image f of x, no? G of f of x we can write. That is the definition. Okay, how it is denoted means G circle F, and it is defined as G circle F maps from A to C. This is G circle F. It maps from A to C. And how it is defined means G circle f of x is g of f of x. Just now we have seen here for all x belongs to a for every element like that. Quantifier I wrote for all quantifier it is for all for every. Here see what and all. One first important thing is this definition alone. That is g circle f of x. You should be able to define that is g of f of x. That is important. And another important condition is here codomain of f, that means b, that must be equal to domain of z, because composite function means it is relation between two functions. No, here first function codomain and second function domain are equal, then only we can link. And also domain of f will be equal to domain of the composite function g circle f, and codomain of g will be equal to codomain of the composite function g circle f. Okay, these and all things can be noted. We'll do some small illustration, then we'll get an idea. Okay, we are not using definition or not doing any questions, just we write an illustration. Okay, we will give two functions we took, f maps a to b and g maps b to c. Okay, and how they are defined means the order pairs are given in f. How they have given, so I can write like this for our understanding. Here see 1 maps to 2. Okay, next 3 maps to 4, 5 maps to 2, and 7 maps to 4. This is how the function f is defined. Now see G circle f, how what kind of order pairs are there? You see 2 maps to 11. Okay, next 6 maps to 11. You see here 6 we do not have. Here we do not have in range of f. So 6 will write aside. That is not required for us. 4 maps 30. And you see here 2. Again this 2 maps to 11. I will write here. 5 maps to 2, 2 maps to 11 like that. I can link. I can write the composite function next. Next to see 4 maps to 13. 4 is there here in range. 4 maps to 13. Here also 4 maps to 13 we can write. 8 maps to 13. 8 we are not having in the range, but it is there in codomain. So we'll write aside. This is G. Now G circle F, if we want to write 1 maps to 2, 2 maps to 11. So 1 maps to 11 straight away you can write. And 3 maps to 4 and 4 maps to 13. Similarly 5 maps to 2, 2 maps to 11. So 5 goes to 11. 7 maps to 4, 4 maps to 13, 7 maps to 13. So now we can write G circle F. G circle F will contain order pairs like 1, 11, 3, 13, 5, 11, and 7, 13. Okay. See, suppose if you want F circle G. F circle G is defined. First we have to write G. Z means what kind of order pairs are there in G? 2 maps to 11. Okay. Next, 6 maps to 11. 4 maps to 13. 8 maps to 13. If you write F, next we have to write F for F circle G. So F means what? 1 maps to 2, but 1 is not here. So we can write aside 1 maps to 3. No, we do not have. 5, we do not have. 5 maps to 2, 7 maps to 4. So here, see, it is not possible. See, why it is not possible means codomain of Z and domain of F are not same. Then we cannot have a composite function. So F circle G is not defined. Okay, if it is defined also, G circle F and F circle G are not equal. So composite function doesn't satisfy commutative property. Okay, so this is the definition of composite function. Okay, we did a basic problem. See. Okay, next class we'll discuss some higher end questions. Thank you.